Assalamualaikum warahmatullahi wabarakatuh. My name is Fatil Zaidatul Akmal binti Hamzah and I am from Group EE2414C. So today I would like to present my Lab 1 report, which is ARM Assembly Language Programming, Data Transfer, Data Processing and Addressing Mode. So for this lab, the learning outcomes of student which should be able to write a simple assembly language programs for the ARM microcontroller by using data transfer and data processing instruction and addressing mode. And then student also should be able to execute the programs by using an ARM kiosk editor, assembler and simulator. Okay, for the exercise 1, ask about the program. To write the program that we store 0 times 30 into the R0 and then copy the content of R0 into the R5, then save the data 0 times 4578561 into the memory location, which is 0 times 400030, and then execute the program. Move instruction used to load 0 times 30 into the R0. Second, move instruction used for copy the content of the R0 into the R5. LDR used to load 0 times 4578561 into the register R1. For the LDR, load into the register R2 0 times 40000030. STR used for the store content R1 into the memory pointed by R2, and the change of the memory will not shown in the register, but it will show in the memory. So I will try to run this program. Okay, from this, move R0 times 30. So from the register shows that R0 is equal to 00000030, and then I will start over for the next line, which is copy the content of the R0 into R5. So meaning that the register in the register R5 is also shown as 0 times 00000030. After that, load into the register R1, which is R1 shows that 0 times 4578561. Also, R2 is equal to 40000030. For the STR, which is store the content of R1, memory pointed by R2, shown that in the memory shows 12, 56, 78 and 45. Question 2. The program let us to perform the addition instruction. We use LDR to load into the R1 0 times 20FE5690. LDR also used for load into the R2 0 times FE123089. LDR3 load into the R3 0 times 3458910 respectively. For the add as instruction, used to add the content R1 and R2 and save into the R3. For the second add as, we will add again and save the sum into the R7. The CPSR will change and record the value. And then I will try to run the programs. For the R1 is equal to 20FE5690. For the R2 is equal to FE123089. And for the register R3 is equal to 0 times 345897010. For the R4 is equal to 0 times 1F108719. And it record the carry becomes equal to 1. And then for the R7 will equals to 0 times 5369181. The carry will become 0. For the next question, question 3 asks to write a program that restores 0 times 2936 FDA in the R8 and then perform the instruction, which is logical instruction that use ASR, LSL, and ROR. So from this program, I use LDR to load 0 times 2936 FDA into the R8. And then ASR, which is instruction which rotates the content R8 4 times. LSL, instruction which is shift to the left 4 times. And then ROR, the instruction which is R7 is equal to R8, is rotate right 4 times. So I will try to run for the ASR first. Okay, for the LDR-R8, so register in R8 is equal to 0 times 2936 FDA. And then I will start over. So ASR, the new value of R7 is equal to 0 times 02936 FAD. From this we can see that LDR is equal to 0 times 2936 FEDA, and then we start over. The new value of R7 is equal to 936 FEDA0. That's for the LSL. So we move to the next. For the ROR, LDR R8, register R8 is equal to 0 times 2936 FEDA. And then the new value of R7 will equal to 0 times 936 FEDA0. For the question 4, ask to perform logical OR. And then in these programs, I use LDR, which is to load 0 times 6398 into the register R1, and load 0 times 1 DFE into the register R2, and ORR to perform logical operation ORR where R1 and R2 and save into the register R3. So from this you can see that for the R1 register R1 is equal to 0 times 0006398, and for the register R2 is equal to 0 times 1 DFE. For the ORR, R3 is equal to 0 times 00007 FFE. So for the question 5, we use LDR to load 0 times 4004000 into the R0, and 0 times 4004000 into the R1. Then we use MOV because the data insert into the register in a byte size, so that's why it is not suitable to use the LDR. And next, we use LDRP and R3, R0 and hashtag 1, which is the content of the memory pointed by R0 and move to the R3. We use the post index. R3 insert to the content memory pointed by the R1. And we also use compare, which is to compare R2 with 0, whether R2 is equal to 0 or not. So we use BNE, which is branch not equal. If a comparison are not equal to the 0, it will do changes. But from this, we use NOP, which is stand for no operation, that is only used to rest the program. So we can see that the programming will be continued to loop where R2 is equal to 0, so it happened 12 times. So for the MOV, R1 is equal to 0 times 400, 40020. It also will repeat until 12 times. So R0 is equal to 0 times 400, 4001. And for the register R3 is equal to 0 times 00001. We add this 001. And then for the second time, and for the third time, until 12 times. For the question 6, by using the data addressing mode, we set up R2 with a 5 by using MOV, and that we can compare R4 with the R5. For if R4 is greater than 5, the program will jump here and store R4 into the memory location R1, which is 0 times 400, 20000, and if not, it will perform here an addition operation R4. Whereas from this, let's try to build this program. As we can see, R4 is equal to the 0 times 00003, register R2, and this is register R1, and this is R3. So next, from before this, it will compare R4 with the R2. So because of R4 is less than R2, we have to add register R4 will be kept in the memory location here. So that's it. This program doesn't loop because R4 is less than R2. So as a conclusion from this lab, I had learned to know the basic things about the theory that we had learned in the classes, such as arithmetic operation, logical operation, branch and loop instruction. And I also learned how to use skill software and how to execute a program with using the exercise that I have given.